Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about the sum of an infinite geometric series. So there are some geometric series where we actually can find the sum of them. And when we are able to find the sum, that's when our R, or our common ratio, is between 0 and 1. Some kind of fraction, okay? So if we look at the screen, it says, as n increases for any infinite geometric series with common ratio r between -1 and +1. So I said between 0 and 1, but we're just talking about a fraction, so this fraction could also be negative, so technically between -1 and +1. So the value s of n approaches s sub n equals a sub 1, or the first term in our sequence, times 1 minus r to the n, so r being our common ratio, n being the number of terms in our sequence, divided by 1 minus r. Well, if we plug in some values for r, so if we get 1 minus 0 in our numerator over 1 minus r, well, 1 minus 0, that's going to give us a 1, so we multiply across, and that just gives us a sub 1 over 1 minus r. So we can simplify this equation to give us this simplified equation, so to speak, so that we can actually find the sum of an infinite geometric series. So we see down here with the star next to it, our equation that we're going to use today in this video is s is equal to a sub 1 minus, or divided by 1 minus r. Now this is provided the fact that the absolute value of r is less than 1. So if we have the absolute value of r, if our common ratio is greater than or equal to 1, then the series in that case would have no sum. Okay, so technically we have an infinite geometric series, so it has an infinite number of terms, but we would still be able to find the sum of the sequence because, as seen in a previous video about partial sums, there is going to be a value that n is going to approach, or that our sum is going to approach as we continue to increase the number of terms that we have. Okay, so let's look at 3 examples in this video. Number 1, we have sigma notation or summation notation, where we have infinity obviously as our upper limit, and then we have our initial limit, or our starting value of 1, and we have our rule. So 4 times 0.2 to the I minus 1. So we see that our common ratio is 0.2, so that would work here. That's between, or that's the absolute value of that is going to be less than 1. So we can actually use our equation here. So let's say s is equal to a sub 1 divided by 1 minus r. Okay, so a sub 1 is going to be listed right here as 4, because I see this is I minus 1. So now we're going to put a 4 there, and then we're going to divide by 1 minus 0.2. Now 1 minus 0.2 is just going to be 0.8, and we could do 4 divided by 0.8, and that's going to give me a sum of 5. Okay, so the sum of the sequence for number 1 would be 5. All right, number 2, it's just written as a series. It's not in sigma notation, so we have to figure out what our rule is here. So we have -6, -4, or -6 minus 4 minus 8/3 minus 16 over 9, so on and so forth. So one thing I noticed, my signs are not changing. So we're not multiplying by a negative here. We're going to be multiplying by a positive. And so if we go from, I think maybe going from 4 to -4 to -8/3 might be a little bit easier to see. We're multiplying by 2/3, right? So if I do 4 times 2, that gives me 8, and then we have a denominator of 3. So now we know that r is equal to 2/3. And this right here is our first term. So now we can go ahead and find our sum, because our r value, our common ratio, is less than 1. It is 2/3. So now we're going to say s is equal to -6 over 1 minus 2/3. So s is equal to -6 over 1/3. So -6 divided by 1/3 would be like -6 times 3. So that's going to give us a sum of -18. Okay. All right, and the last one, number 3, we have 2 plus 5 plus 25 over 2 plus 125 over 4. So if we look, how are we increasing our values here? What are we multiplying by? Well, to go from 5 to 25 over 2, we're multiplying by 5 over 2, right? So our common ratio is 5 over 2, or we could say that is 2.5. So we look at that r value. Is that greater than 1? Yes, it is, right? So we would say, because r is greater than or equal to 1, the series has no sum. Okay? And that is how you can find the sum of an infinite geometric series.